Hello, everyone, and thank you for joining us for today's webinar hosted by our Solutions Engineering team. Today, we will discuss how to use HashiCorp Vault to securely deliver secrets to applications when we often run into that chicken and egg scenarios. I'd like to introduce you to our presenter today. Teddy is a Senior Solutions Engineer at HashiCorp. Teddy is going to introduce how authentication in Vault works, give an overview of the AppRole auth method, and explain how it integrates with Terraform and Chef. Next, Teddy will go into a live demo and then answer questions from all of you. I also want to note that this webinar is recorded and the recording will be made available after post-processing, usually within a day or two. I'll email it out to all of you. With that, let's go ahead and get started. Take it away, Teddy.
All right, let me unmute myself first. Let me figure out how to change presenter. Okay, I think I'm presenting now. Perfect. So let me share my screen. Screen 2. All right, so hopefully you're seeing my slide deck right now. Let me just put it in presentation mode. Perfect. All right. Okay, so we're here. First of all, my name is Teddy Sakalowski. I'm a Senior Solutions Engineer here at HashiCorp. And the webinar today is going to be about secure introduction, specifically about using Vault's AppRole authentication method, and using Terraform and Chef to kind of help put all that together. Little information about me. I've been a Senior Solutions Engineer here at HashiCorp for about a year now. It's been a really fun ride so far, really great team and a lot of great products. So really happy to share some of this information with you. And I also have the link to the demo repository that I'll be using towards the end of this webinar. So let's go over agenda real quick. Firstly, I introduced myself already, so that's taken care of. Just to preface, the webinar is going to have a lot of conceptual material. The demo part itself is going to be pretty short because ultimately when, AppRole just works and it's a pretty simple thing to get to work. But the more important bits are going to be the actual source code, what's happening in the background to make everything come together. So I'll spend a lot of time looking at that. Where I'll start off is actually kind of talking about a blog post that Seth Vargo had and a webinar that he had put together, I think in 2016, that kind of talks about different integration patterns between Chef and Vault. There's some missing pieces there, so I'm going to want to kind of close the loop with that, and AppRole is a part of that. And kind of then just building the story, adding the proper context to understand AppRole, specifically around understanding how authentication in Vault works in general, building up to the idea of secure introduction in general also, and then finally learn about AppRole and different patterns and how ultimately it helps with the concept of secure introduction. So let's get going. So I mentioned back in February 2016, Seth Vargo used to be a director of technical advocacy here at HashiCorp, wrote a really good blog post kind of talking about integration patterns with Chef and Vault. If you've ever Googled, how do I use Vault with Chef, you'll likely have come across this and you've read through it and you understand at a high level the different types of patterns that are available. But even in the blog post himself, Seth mentions that there are some missing pieces that he doesn't cover, namely about the story around authentication. So this webinar is going to kind of focus around closing that loop. Highly recommend, if you haven't seen the webinar or the blog post yet, definitely go through it. It's really going to help add a bunch of additional context here. So let's talk about authentication. Ultimately, what AppRole aims to solve is providing a way to authenticate in a secure manner. Vault is, I'm going to assume everyone has some concept of what Vault does. Ultimately, it's around centralized secrets management. We have static secrets that might live in our in the encrypted KV store. We might have dynamic secrets, which are kind of our just-in-time, on-demand credentials for like databases, AWS, API access keys, and and providing a programmatic way to access those secrets. With the current trends in modern application development and cloud-centric everything, all of our things are essentially very dynamic and very distributed, or at least we hope that they are, right? We're trying to address a level of scale that's increasingly growing and very heterogeneous. So the idea here is, well, we can't and continue to depend on humans to deliver these secrets. We're inherently not the most reliable creatures out there, and more importantly, we can't scale to the way that we're doing things currently. So we need a programmatic way to do this, and this is kind of what Vault provides. So we have our secrets; they're all living in Vault, and now we need a way to get them. And obviously, as a client, whether I'm a human client or a programmatic, let's say a machine, an app, or a container, I need a way to prove I am who I am to our Vault server to authenticate and get what I need out of it, right? Vault provides a lot of different authentication approaches, whether we're talking about human-oriented ones like LDAP or AD integration or Okta, or whether we're talking about programmatic access like our AWS authentication backend, Google Cloud authentication, whatever authentication backend we have in Vault, ultimately maps down to the issuance of a token. And this token is what essentially we have policies attached to, and that's our authorization part, right? And there's more nuance there, especially when we start talking about identity and Sentinel. But for the sake of this conversation, policies are attached to the tokens. And the tokens are essentially what we provide with every subsequent API request or operation that happens thereafter. So if I'm a web application and I want to pull a database secret from Vault, I need to provide that token to allow me to do so. So with all that in mind, we're talking about authentication and we're talking about the delivery of a token. The question then becomes, how do we securely deliver these authentication tokens to our programmatic clients, right? The story around humans is pretty easy, right? We log in with the username and password, we get a token, and we do something with that token. But how does an application do this, or how does a container do this? And how do we get that programmatic entity their token? And this is ultimately the challenge that we're trying to solve. And we're using the concept of secure introduction to solve it. So what is secure introduction? Small little aside over here. I have a link over here to a talk that our lead Vault engineer, Jeff Mitchell, gave, I think it was last year at a HashiConf, specifically around managing, actually, no, I think it was the year before, but it's about managing secrets in a container environment. So although the title sounds like it's really geared towards containers, his approach is really a really good approach around building the entire context around secure introduction, starting from your security principles that you want to adhere to, and kind of providing the patterns that can be used. So I highly recommend also watching that talk to add additional context here. Part of my goal here is to provide not only my content, but loop in all the other things that kind of add additional context, and that's a very good talk. So back to secure introduction, right? I want to securely deliver that first secret, that token that applications or containers or servers can then use to pull what they need to do what they need to do. I mentioned earlier that Vault has a number of different authentication capabilities. We're really becoming a de facto broker of cloud identity. And I have a link here on the slide. You'll see kind of pointing to a blog post that our illustrious leader, Armand, put together talking about this concept with some additional context that I think will be super informative for folks. But the idea is that we have a number of different authentication approaches, and a lot of them are built off of the native authentication and identity capabilities within the different cloud providers. So for example, let's take the AWS authentication backend. Every EC2 instance, and this is a simplified kind of description, but gives a lot of good context. Every EC2 instance that's deployed into Amazon has a metadata service internally built into it with a lot of different pieces of information, along with a cryptographically signed identity document, right? So I might know that I have a specific instance profile attached to the EC2 instance. I know obviously what VPC I'm located in. I know what AMI ID that was used to build this instance. There's a lot of pieces of information. And that cryptographically signed identity document is essentially a way that I could trust that EC2 instance. We trust that AWS knows what they're doing and that they have signed this document, and that we could use that as a source of trust in a sense. So the story there is super simple. The EC2 instance essentially does a login request, an authentication request against Vault, presents that cryptographically signed identity document. Vault then verifies that against the AWS APIs and says, yes, you are who you say you are. Here's a token. And now that EC2 instance can do whatever it needs to do, whatever that token permits. Really easy, simple story around the idea of securely introducing that token. And we have a number of other authentication backends that do similar things. We have something similar for Google Cloud. There's a Kubernetes authentication backend that helps deliver tokens to pods. Again, the idea here is that we don't want to be a source of identity, but we're brokering all the existing sources of identity that are out there as a way to be cloud agnostic and deliver these secrets across multiple platforms. But there may be some limitations there, right? So I talked about the EC2 authentication. I might have multiple services running on my EC2 instance, or I might be running in a private cloud on-prem where I don't have that authentication capability. Any number of potential reasons that may not be enough, or I might need to get more fine-grained. We do have, however, more likely than not, a number of different systems that are involved to deliver our applications, right? We essentially have what's called a circle of trust, and Jeff Mitchell talks about that in his talk. But we have a number of systems in our environment that are ultimately responsible for helping deliver our application. We might use Kubernetes, for example, for container scheduling or orchestration, or we might use HashiCorp Nomad. Or both even. We have a lot of cases of that, right? We might be using Terraform for provisioning our infrastructure. We'll certainly have some semblance of configuration management, whether we're using Chef, Ansible, Puppet, insert whatever other configuration management tool you prefer. And more likely than not, we'll also have some kind of CI/CD pipeline. Maybe I'm using Jenkins to build a Packer image that then gets deployed using Terraform, but it uses Chef to kind of do the configuration management, right? So you see the pipeline here, you see how things kind of mix and match. And so we have this circle of trust, and we trust these systems to do things. So maybe we could use that, right? Like if we're already using these things, maybe we can use these to provide some sort of secure delivery of our tokens. But the question then arises, how much do I, or should I trust any of these systems, right? I might really trust my whole Chef server infrastructure, for example. I might believe that there are going to be no bad actors, and I could give Chef a fairly privileged token to pull database credentials, let's say for a web application that it's deploying. I might do that. And if that's the case, certainly absolutely do so. It's valid. It's certainly a valid pattern, but it doesn't necessarily speak to the concept of least privilege, right? In security, we want to try to reduce the links in this chain of trust, or at least reduce the amount of trust that we put in any one system. But what do we do, right? I have these tokens that I need to deliver, but I want to try to reduce the amount of trust that I have in any one of these systems. How can I solve that, right? And really, it comes down to this. I mentioned that there are likely at least 2 of these types of systems involved in delivering an application in your environment, and whatever environment that might be. And I went back a slide just so you see some of these different systems again, right? So I have at least 2 of these systems going, running in my environment. And what if I had a way now to, instead of delivering an actual token itself to my application, what if I had a way to distribute a piece of an authentication to my application, where that one part by itself doesn't give me anything other than just a piece of an authentication. And ultimately, that's what AppRole allows us to do. So let's talk about AppRole. What is it? An analogy I like to use that helps me at least is kind of thinking about the concept of AppRole as a username password metaphor, but for machines, right? Ultimately, we're splitting up the authentication operation, or the delivery of a token, essentially through 2 different pieces. We have a role ID, which is a static identifier that basically it identifies our role. So we create an app role. Let's say we're creating an app role for a web application, and that web application is going to be deployed over a cluster of nodes. Every one of those nodes will share that same role ID, because ultimately that's how we identify what the role is for this app role authentication. It's not considered a sensitive or secret value, meaning I could embed it into my AMI as an environment variable. I could check it into GitHub along with my app code. I could put it in a Docker file as an environment variable. Any combination of those things. It's not considered sensitive. It's a static identifier, and by itself, it doesn't give me anything. I can't take a role ID and get a token with just that. I need the other piece, which is the secret ID. And the secret ID is a value that is considered somewhat sensitive, maybe even secret, right? Ultimately, though, it should be unique to each client, right? Because the combination of a role ID and a secret ID will result in a unique token. So I want to make sure that each of my clients, each of my nodes have unique tokens. This helps, with this one-to-one mapping between a token and a client, helps with the whole concept of non-repudiation. And this secret ID might be delivered in more of a kind of on-demand, or maybe a just-in-time type of configuration, right? I might deliver it through Chef. I might deliver it through some other configuration management, maybe as part of my orchestration system, etc. There's a number of different options, but the ultimate idea is that I'm delivering through a separate channel than the role ID. And similar to the role ID, I can't do anything with just the secret ID. Again, it just is a value without any context in that regard. But the fun thing is when I actually bring them together, right? And that's how I ultimately get my Vault token. So the idea is ultimately the role ID and secret ID should only ever exist together on my final target. And then I bring them together and I get a token, and now my app or whatever can do what it's supposed to do, keeping in mind the permissions, the policies that are attached to that token. So let's kind of really drill this whole idea in with a picture, because pictures help a lot, right? So really just going to reiterate everything I just said. Here we have, on the left-hand side, we have our Vault server. A Vault admin has presumably already set up the app role, provided the different created the different limited tokens, right, for each of our trusted systems. On the right-hand side, we have our targets. These are our, application servers, our applications, our containers, the thing that actually need that final token. And in the middle, we have our trusted systems, the things that we have some trust in and we have in our environment that do things. And that might be Terraform for provisioning, Jenkins for CI/CD, Chef, Nomad, Kubernetes, PCF. I mean, any of these different things that sit there to help us deliver our actual value as an organization, which is our applications, right? So the thing that I want to drill in with this picture is that AppRole is a pattern. I'm specifically going to be talking about an instantiation of this pattern using Terraform and Chef. But by no means do I want to imply that you can only use things like Terraform and Chef to use AppRole. But just giving kind of an overview of what's going to happen in the demo once I get to it is I'm essentially spinning up a Chef and Vault server. I'm running it on the same server just to keep things simple. And I have Terraform doing the actual provisioning of a Chef node. Terraform is going to be responsible for delivering the role ID to that Chef node. It's basically going to dump it as an environment variable. And I only need now to give Terraform a very limited token that can only pull a role ID from my AppRole definition, and that's it. So I don't have to necessarily be super concerned if I have a bad actor in Terraform and they get that token and they can only pull a role ID from AppRole. Again, the role ID by itself can't do anything. Similarly with Chef, I'm going to give my Chef server a very limited token that can only pull a secret ID. I'm going to put it in a data bag. Chef provides a lot of different ways to kind of secure pieces of information with their own pros and cons. So I might have, a data bag which essentially stores things in plain text. I might use an encrypted data bag, or I might use Chef Vault. When I start talking about the more secure methods of those storage options, this is kind of where I run into the whole chicken and an egg concept, right? If I want to use an encrypted data bag, I have to provide a secret to my Chef client, and how do I protect that secret, right? But if I'm using a limited token that can only pull a secret ID from Vault, I kind of insulate myself from that. I could use a more simpler approach to storing that token, and worst case scenario, if it gets compromised, I'm really only pulling a secret ID, which again, very limited functionality, right? So let's go into a demo. So for the demo here, like I said, the actual demo part is it's pretty quick. I'm going to run a Terraform apply, and it's going to just work. And I'm going to do that now, actually, just to get that started. But the more important bits are going to be what happens behind the scenes. And I'm going to take some time to kind of to walk through that. Let me just confirm this. I mentioned earlier that there's a repository where this demo will live. The engineers here at HashiCorp have started to put together a guide a repository of different guides for Vault and for our different products to kind of help users learn the different features that are available and how to apply them. And this is where the secure introduction demo is going to live. And what I'm doing here is basically I have a README that talks through the setup of everything. One little segue I'm going to mention here, I do also include a number of references in my README, talking about the blog post and webinar from previous, talking about Jeff Mitchell's talk, and a number of other things that kind of help with this whole concept of AppRole, specifically around Chef as well. So I highly recommend looking through it. So let's see what we have going on here then. So the first, essentially the demo here gets provisioned in two phases. I mentioned that I have a Vault and Chef server where I kind of do my initial setup for the AppRole, and I set up the Chef data bag. Let me actually increase the size of the fonts here just to make sure everyone can read. So I'm not going to dig into the actual provisioning of that server too much. It's fairly simple. What I will talk about actually is how we set up our AppRole, because that's the more important piece, right? So once I have Vault up and running, I've initialized it, I've unsealed it. I now want to create my AppRole. So if we kind of look back at the slide I had with the picture over here, I'm almost starting backwards where I define what I ultimately want to be delivered, and then I kind of fill out the pieces to the left. So we create our AppRole. The first part of that is, what is the policy? What do I want that ultimate token to be able to do? So I have to define a policy around that. And I'm using the API calls here just because more likely than not, those are what you'll use in any type of automation. So I wanted to provide that as an example. But essentially I have here a policy that I'm defining. I'm basically I have a secret that's written to my secret/app1 KV backend. Again, this path is arbitrary. It's whatever you ultimately want to read from in Vault. And then I have the capabilities that I want to define for the ultimate AppRole token that will be delivered. More likely than not, this is going to be delivered to an application. So the trend is usually applications are the readers and the human admins are the writers, or some combination of that, right? So in this case, I'm providing a token that will allow my application to read or list the values in my secret/app1 path. That's writing the JSON for the policy. And then now I'm actually writing the policy to Vault with this curl command. I'm passing the JSON file as the data, and I'm naming essentially the path that I write it to is the name of the policy that's going to be used within Vault, which is app1 secret read. All right, great. So we've defined our policy, right? Now I want to actually apply the policy and create a role within my AppRole authentication method. To do that, I first need to enable the AppRole authentication method, and the enabling action is very simple. I just give it, a description and a path where I want to mount it to, and that's what's happening here. Now the fun part. Now is where I actually configure the AppRole itself. So I've defined my policy. I've enabled my AppRole authentication method within Vault, and now I want to create an actual role within that authentication method. And this is a subset of the configuration items that can be set, but it gives a very good overview of the different pieces that can be set. So I have the name of the role. That's self-explanatory, right? I want to call it my app1 role. I have a time to live and a number of uses for my secret ID. So Chef is, again, going to deliver this secret ID to its client. I could put some additional restrictions around on that secret ID to kind of add additional layers of security. So I could make sure that that secret ID can only be used once. So even if someone somehow manages to intercept the delivery of that secret ID, if they use it, that counter will essentially set to 1. And then if my actual client tries to use it, they'll get an invalid token error. And I might use that for some kind of active alerting or something, for example. If I get this error within the TTL of that secret ID, it means maybe it was intercepted at some point. Let's do something about it. Then I have the actual token parameters that I want to set, right? I have a time to live for the token that's going to be delivered after the AppRole authentication. And the max TTL. And the difference there is, ultimately how many times can I renew it to the max TTL of that token. And how you configure these values is ultimately going to depend on the life cycle of the client. So if I have a fairly immutable infrastructure and maybe I'm rebuilding everything weekly or every 30 days or something like that, I'll set the token values in an appropriate manner that basically maybe will give me some leeway, but might be within that time frame. If I want the role ID and the secret ID to live in a more persistent manner on my client, I might give the secret ID a longer time to live and a higher number of uses. It's really kind of the question around, am I using more immutable or more persistent type of resources, and what the life cycle is there. But you have a lot of flexibility ultimately how you do that. So this is, again, just kind of creating the JSON file with the configuration. And then, again, I just do the curl command to write that. And I'm writing it out to my AppRole role, which I'm calling app1. All right, great. So now I have my AppRole configured. The next step is going to be to configure the tokens that I want to give to Terraform and Chef. And again, the goal here is I trust these systems, but not completely. I want them to play a part in the delivery of a token, but not have the capability to pull a full token, and therefore all the things that token can pull. So I need to create somewhat limited tokens, right? So again, keeping with the pattern, I need to create policies first that are going to define these capabilities. For the Terraform side, there's actually two policies that I'm writing. The main one is the one allowing Terraform to pull the role ID from my AppRole, and that's the path that I'm kind of have highlighted on the screen right now. Everything involved has canonical pathing approaches, right? So I know all my authentication backends are going to be listed under auth. I've called my AppRole authentication backend AppRole. And then I've given it a name app1, right? I always get the role ID for that specific AppRole under this path. And it's a read operation. So, okay, I've defined a policy now that is going to allow me to only read the AppRole role ID, and that's it. And I'm writing the policy again using the curl statement. This second policy is specific to Terraform. The way Terraform uses Vault's tokens is it actually creates child tokens under it so that it deletes them once it's done doing whatever it does, so that that's never exposed, like in a state file, for example. So that's what this whole policy here is doing. And then finally, now that I've defined my policies, I want to configure a token for that's going to be used to grab this role ID. And that's what this section here is about. So firstly, I'm creating my configuration. What are the policies that are going to be attached to this token that I'm giving Terraform? And those are the policies that I've just defined above. I can add some arbitrary metadata to the creation of a token. So if I want to keep track of what that token was used for, I could add, like I said, some metadata there. And then the time to live and whether or not it's renewable. The time to live here, you'll see it's 720 hours, 30 days, I think, essentially. And the idea there is that because it's a limited token and it's going to be used by a system in our environment that we have some trust in, we could give it a longer lived token so that we don't have to constantly be renewing that, right? If I'm using Terraform Enterprise, I might scope it specifically to a workspace, for example, and it'll live there and do what it needs to do. And then finally, I'm pulling that token. Here, I'm writing it out to a JSON file just so I could kind of keep track of it and use it later. And this is what that JSON file looks like. It's the token along with all the additional metadata associated with that token. But this highlighted piece is what I actually give to Terraform. The next step is going to be to do that same exact thing, but for my Chef server and for my secret ID. So I won't go into too much detail here, but I'm essentially doing the same type of thing. One thing I will point out though, if you see the policy that I've defined here, the capability I'm giving it is an update capability. So I keep saying pulling a secret ID from Vault, but the actual operation is a post operation. We're creating that value first and then getting it back out. So that's why you see the difference here between a read and an update. Just heads up on that. But same type of thing. We're defining a policy for the token. It's going to use that policy that allows us to only pull our secret ID from our AppRole path, and only that. and then I create the token. And I mentioned earlier that I'm going to put this in a Chef data bag. Well, again, what that looks like is similar JSON file. I have my client token, right? And I'm actually going to dump that entire JSON file, that entire metadata, into my Chef data bag. So I have some commands here where I'm adding an ID field because data bag items need to have an ID field, but I'm using that same JSON file and I'm putting it into my data bag. And ultimately, this is what that looks like. So that's really the setup. I'm not going to actually go through and set all this up in my demo because I've already scripted through that to keep things quick, but I did want to step through to show you what's actually happening. So this gives us an idea of what I've done to set up our AppRole. So now let's take a quick look at what's going to happen in the background. Firstly, let's look at our Chef recipe, because that's probably what everyone's really curious to see is all right, how did he actually set it up to talk to Vault? The recipe here is really simple. I'm just running, I'm just installing Nginx and creating a custom index.html file that's going to output these different values. This is a very simple illustration, very simple example. There's a lot more you could do with it, and that's kind of where Seth's blog post goes into play. But I wanted to provide a simple entry point and set the context, which you can then take and kind of expand on and evolve and mature. Ultimately, you'll likely end up using the Vault Ruby gem that we support. It makes it super simple to interact with the Vault APIs. And that's a really simple way to kind of do what you need to do in your Chef recipes. So this is me just pulling that Vault Ruby gem, installing Nginx, and now the important bits, right? So the Vault Ruby gem essentially exposes a Vault client. I need to give it address to tell it where my Vault server actually lives. I've embedded that on my Chef node, the actual client, as an environment variable using Terraform. And I've also embedded that role ID. So here's the actual piece where, you know, I assume already that Terraform's gone through the process of provisioning my instance. Using the user data field, I've told it to write the role ID out to an environment variable. So it now exists on that server, right? So my Chef server never actually has that piece of information. And then, you know, I'm going through the process of pulling that token, the token that I'm going to use to retrieve the secret ID from my Chef data bag. I'm going ahead and authenticating with my Vault client using that token. I'm pulling the secret ID. And again, I keep saying pulling, but you see here it's create secret ID. That's the whole update mechanism that I mentioned earlier, but that's getting my secret ID. And then finally, the really fun part, like I said, not super complicated. I'm doing an AppRole authentication. I bring my role ID that I've pulled from an environment variable and the secret ID, which I just pulled in the line previously, and I'm doing an AppRole authentication with this Vault client. And that gives me a token. That gives my Chef recipe that's running local to my Chef client a token, which I can then use to read from my secret backend. I mentioned I wrote some arbitrary data to secret/app1, and I'm using that token to pull from there. And I'm just kind of writing out some information to my to an index page. So let's see if the demo gods were friendly to me today and if everything worked. And it didn't. All right, awesome. Let's just do another apply. Of course, that would happen. There is a small bug that occasionally rears its head, and I'm trying to figure out why that comes up. But certainly, if anyone else starts playing around with this and comes across it, feel free to put a PR in for that. But more likely than not, I'm just going to do the reapply, and it'll work. And I'll be able to show you the end result. And this is why I mentioned earlier that the actual demo part itself is pretty quick because it either works or not. I guess while that's running, let me talk real quick about, where was that? About what's happening on the Terraform side. So I mentioned I'm using Terraform to provision my instance and to pull the role ID from Vault. We have a number of different providers that help out with these types of things. So you see over here, I'm using the Vault provider. I'm passing in the Vault IP address for the Vault server and the token that I want to use. Typically, you probably set these as environment variables, but I'm showing it here just to make it explicit. And the important bit here is the actual data that I'm pulling from Vault, which is the role ID. So that's kind of where in the Terraform code I'm pulling that. And the other piece here is the chef provisioner for the instance that I'm creating, right? So I'm using Terraform to provision an AWS instance. I want to use a chef provisioner to bootstrap that instance with my chef server, which is already up and running. And I want to provide a run list of the recipes to run when it comes up, and that's what I'm doing here. Really neat feature for Terraform to kind of do that automatic bootstrapping. All right, let's see again. Wow, okay, it failed again. This is weird. I ran it 5 times earlier this morning and it worked without a problem. Let's go to the README. I'll show you what you're supposed to see ultimately, and then we could kind of go into a Q&A session instead of hoping that this works again. Ultimately, what you're supposed to see at the end is provision. I'm basically just getting a web page that shows the role ID, the secret ID, our AppRole token, and our secrets. Really nothing crazy. But of course, I'm doing a demo, so the demo gods are not friendly today. So I think at that, I'll leave it, and I think we could go to a Q&A session, and then if this comes up, I could just circle back and show you how everything's working. So let's move into that.
Okay, Teddy, thank you. So the first question, someone's wondering if you can explain what it means to wrap secrets.
Sure, that's a good question, actually. I didn't go into that. So I mentioned, we talked about, let me bring up the slide real quick. So we talked about, we have this whole picture right here. We're providing a role ID through Terraform, and we have our secret ID, and I might have it wrapped. So an additional layer of security, Vault provides a capability called response wrapping. So if I really want to make sure that no one on my chef server can actually get that secret ID, I can essentially, it's kind of like envelope encryption in a way where I'll wrap that secret ID value with another value, and that essentially means that I could only unwrap that value once. So it's kind of like the thing I alluded to earlier with the thing where if that secret ID does get unwrapped and I'm able to retrieve that secret ID, I can't use that token, that wrapped token anymore. It's only kind of like a one-time use thing. So then if I ultimately deliver that wrapped secret ID to the client and the client tries to use it, and they get an invalid token error, I can raise an alarm that something was intercepted along the way. Let's inquire what's going on. So it's just another layer of security, kind of to wrap that whole secret ID and give us a way to know that something might have happened along the way in the delivery of that.
Okay, great. And then next question is, how could that be integrated with AWS KMS, or is that actually an alternative to KMS?
So this is essentially, for lack of a better way of stating it, it's kind of an alternative to KMS, right? One of the approaches here is I want to remain somewhat cloud agnostic, or I might want to implement this pattern on-prem where I don't have KMS. KMS does provide really good capability for managing encryption keys and doing decrypt encrypt operations, but this isn't really that, right? This is more of a way to deploy a secret. And I could certainly use Vault in conjunction with KMS, right? I could create encryption tokens on Vault and export them and use them as a CMK in KMS. But we're kind of talking about a different thing here. This is really delivery of, like, say I have a database credential that my web app needs to use, and it lives in Vault, and I need a way for that web app to pull it out of Vault. I need that token. This is a way to kind of do that. Yeah, so it's kind of two different things in that regard.
Okay, great. So then next person is asking that since Chef bootstrapping only works with servers, they said they had this kind of solution using Cubbyhole. How would they do this where something is launching their applications for them, like Amazon ECS?
Sure. Okay, that's a good question, right? So there's a couple different things that, and by the way, the demo actually worked this time. This is what you're supposed to see. So in terms of Cubbyhole and how I might use something with ECS, there's actually two different things going on there, right? Cubbyhole is really that whole concept of response wrapping that I just talked about, right? We talked about it in the context of a secret ID, but the idea around Cubbyhole is that I have this wrapped thing, and it only has like a one-time use. It has a spot that we store it in Vault, and then once I unwrap that or use that Cubbyhole value, that value is deleted out of Vault. So it's kind of like a one-time use wrapping thing. And I don't have to use it only for a secret ID. I could use it as part of the delivery of a token, maybe instead of using AppRole, right? But the other side of the story here is ECS, right? Kind of talking about containers, or maybe even Lambda functions, so on and so forth. You don't necessarily have to use something like AppRole for that, right? It might be part of the story. Kind of going back to what I was talking about with the AWS authentication backend, I focused a lot on the EC2 authentication aspect, but there's also the IAM authentication capability within AWS, where I could use things like STS and assume role, and the inherent idea that things have an IAM role attached to it in Vault. In AWS. So that's a pattern that might be used, or I might even layer different things, right? Kind of going back to the EC2 example, I might have multiple services running on my EC2 instance, and yeah, I could use the AWS EC2 authentication to do something, but I want to have more fine-grained tokens for my services. I might still embed a role ID into my application code, or, assuming we're using AppRole, into my application code, or even a container or whatnot. And I might use the EC2 or other AWS authentication aspect to provide the secret ID through that mechanism, right? Maybe that AWS authentication can only be used to grab a secret ID instead of using Chef, right? So it's another potential pattern that's available. So it's really all about different patterns. We provide a lot of flexibility, but I'd be certainly curious to kind of work through some additional examples.
Cool. Okay. Next question, Teddy. So they're asking, how do secrets needing refresh play into the Chef life cycle? So
Right.
retrieving credentials for an SQL backend and those credentials expired, how would the file be updated?
Sure, that's a good question, right? So for this, I'd actually defer back to Seth Vargo's blog post, right? Because the idea here is that now, say we have something that has a more persistent life cycle that exists for a while. So I don't want to tear it down, bring it back up, and give it a new token. I want to continuously renew something. So I might, the patterns that Seth talks about in this blog post kind of address the pros and cons of different approaches, right? I took a really simple approach of kind of pulling a static value. But if I wanted to manage these more dynamic tokens, database credentials, for example, I might use, maybe method number 2 here, I think. Is this 2? No, actually method 1, sorry. Reading secrets at runtime, right? So instead of Chef deploying let's say, deploying the actual secret, whether it's a secret ID or a token itself. Instead of Chef doing that part, what I'm telling Chef to do is to deploy the application that might use those database credentials and something like console template. And I'm giving console template a token to do what it needs to do. So for anyone that's not familiar with console template, we have two things, console template and env console, ENV console. These are sidecar applications that help with managing the lifecycle of dynamic credentials in Vault. The naming is a bit unfortunate because they were originally written for console to watch like KV paths and do things when things change. But they work really well for Vault as well because they have logic in it that can be used to update. So like console template, for example, is focused around updating configuration files. So I might, tell console template to check this this specific path in Vault to grab a token. It's aware of the TTL of that token, and it'll know to try to check and renew it at half that TTL, for example. When it renews it, it'll update the configuration file, and then it has an orchestration component that can then kick off my service or reboot my service to use that new credential. So, I highly recommend looking at this blog post and kind of understanding what goes on there. The webinar here is to kind of try to close that loop that we even talk about. He even talks about here at the bottom, the missing pieces. How do I actually do the authentication? And Seth does talk about App ID, which is what AppRole used to be, and Cubbyhole that was brought up earlier. So this helps to kind of tie everything together. So hopefully that helps answer your question.
Great. And just to note to everyone, all the links that Teddy has been providing to these blog posts and his slides, we're going to include with the recording when we post it on our website. So rest assured, you can find these links and everything that he's mentioning after and when I send the email to everyone with the link. So the next question, Teddy, someone's saying, so they use Packer to bake AMIs so they can run Chef, then bake the AMI, then share that out. How would you recommend providing the secret ID in that situation?
Sure. So actually, can you repeat that one more time, Amanda? I just want to make sure I get all the relevant bits there.
So they are using Packer to bake the AMIs so they can run Chef, bake the AMI, then share that out. Okay.
So there's two different patterns here, and I'm going to talk about them, both in real, kind of high level, because it's not necessarily clear to me which one we're talking about here, but I get the idea, right? Ultimately, we have some kind of a process by which we're trying to preload as much as we want onto our AMIs. So it might include application code, configuration, so on and so forth. The configuration management piece of it, I might doing a lot of the Chef stuff at the Packer image creation time, or I might be doing it after I provision that AMI. So you kind of have two different phases where you might do configuration management, and you might be using both, right? With this pattern, what I'd say is typically if we're using an AMI per application, let's say, I might embed the role ID through the Packer process as an environment variable, or maybe some text file in a known location. But I can embed that into the AMI. And then if I'm doing a Packer run after that AMI has been deployed, maybe I'm doing that post deployment, like a Converge or something like that, I might use Chef then to deliver that secret ID, after it's been deployed to make it, that one-to-one mapping with the application or the AMI.
Okay, and next question is, can AppRole be mapped to AWS IAM roles?
Can AppRole be mapped to AWS IAM roles? So technically no, right? Because AppRole is just some construct within Vault. However, AppRole is concerned with the delivery of a token, right? If I want that token to be used to pull AWS API access keys, right? Like, because we have a secret backend that generates dynamic AWS API access keys. I can map that token to be able to pull from there. Not sure if that's exactly what you're asking. If you're more concerned about using existing IAM roles, for example, on the AWS side as a source of authentication in Vault, you might not even have to use AppRole for that. I'd highly recommend taking a look at the AWS authentication backend, and I'll AWS auth. I'll bring that up right now, just to kind of give you a really quick overview. It alludes to the EC2 authentication method that I talked about earlier, which is kind of the first way that we did AWS authentication, and that's kind of what this talks about here. But then we also have the IAM authentication method, which is using those IAM roles, those policies that might be attached to different resources in AWS as a source of that identity. So this kind of goes to the whole concept of secure introduction that I was talking about earlier. If you can use the built-in native authentication capabilities within AWS or Google or Azure, for example, I'd certainly try to use them, and AppRole might just fill an additional need or an additional layer on top of that.
Great. Okay. The next question is, and we'll probably take 2 more. With tools like console template existing, do you recommend that approach over some form of code integrated and vault-aware config factory that might handle the renewal of secrets?
The answer is yes or no. I mean, honestly, it really depends. So in my experience, for example, a lot of our customers or potential customers want to use Vault in their environment, but they're still using, I'll say, quote unquote, legacy applications. And I say legacy because I mean, they're not really legacy. We still use them all the time, but they might be based on a configuration file that has secrets encoded in that configuration file. And I can't go through, it's a level of technical debt that I have. I don't have the time, money, resources to refactor those applications, but I still want to add a layer of security that I don't have there, right? So I could use console template in conjunction with Vault to update the secrets in that configuration file, let's say maybe on a weekly basis or even on a daily basis. The idea there is that console template is going to handle the update of that secret and the configuration file and the restarting of the service. Most breaches happen over a long period of time, right? You want to trickle data out, exfiltrate it out slowly so you don't trigger any systems. If I'm changing, a credential on a weekly basis, it's providing a good layer of security that wasn't there. That being said, if you have the resources and the developers and the time to do a deeper integration into my application, why not? I mean, it's everything in Vault is exposed through the API. You'll have to build in the capability to monitor the life cycle of a token or a secret and renew it and so on and so forth. So it's a bit of work, but it's a perfectly viable pattern as well. And again, that's something that Seth talks about in the blog post as method 4, directly integrate into our application. I keep referring back to it because it's an amazing article that gives a lot, the pros and cons of different approaches. So it really I hate to say it, but it depends, right? Depends on your environment.
Great. Okay, Teddy, so I think that is all of our time for today.
Sure.
Thank you for answering all those questions from everyone. So great questions from the audience. Thank you everyone for your participation. I hope everyone enjoyed today's webinar and you're able to learn a bit more about Vault AppRole. Thank you for joining, and a special thank you to Teddy for his time and expertise today. I also want to mention that HashiCorp is hiring, so if you like what you saw today, please take a look at our jobs page at hashicorp.com/jobs and see if there might be a fit for you. And finally, as I mentioned at the beginning, this webinar was recorded, and we will make the recording available on our website after processing. I will send an email to everyone who registered with the recording link. And I will also include all the links Teddy mentioned and his slide deck with that. You can also keep your eyes out on Twitter for the recording. I'll post it usually a little later today. Thank you, everyone. Have a great day. Bye.
Thanks a lot, everybody.